Three developers are going to compete to design a 3D enclosure for a custom PCB in only 2 hours. Ready, set, go. First up, we have Alex Barreau, who's a mechanical engineer and one of the experts inside my Hardware Academy program. Then we have Austin, who's also a mechanical engineer. And finally, we have Alexander, who's not an engineer, but is instead an entrepreneur who's taught himself 3D modeling and design for manufacturing. All three guys are using Fusion 360 for this battle. And here's the board they're going to be designing the enclosure for. It includes an ESP32 wireless microcontroller module, an RGB LED, a temperature humidity sensor, 2 buttons. One is a boot button, one is a reset button, and then it includes a power on LED. And then finally, there's a USB-C port for programming and for power.
I'm going to create a random component and I'm going to throw all of these things into that component so my browser is not as crazy stacked. I'm terrible with names. How do you guys do naming with parts and components?
I have like the same names I use for everything. Like I always have like a top and a back and a body.
Kind of same, yeah. If I do Control F enclosure on my hard drive, I'm doomed.
I'm gonna go a little crazy with it and put some like crazy draft angles just to make it super easy and to kind of give it like a little bit of a flair. All right, got this weird little bump on the back just to make it look a little interesting.
I don't know, but you guys always have the habit of first drawing the enclosure as a big solid to get the final external shape that I want, and then hollowing it out and doing everything else. Is that what you also do?
That's what I'm doing.
Pretty standard, I think.
Set up the outside perimeter and then just shell it, and
yeah, exactly.
It'll copy the drafts and whatnot.
So right now I'm working on making the first outside perimeter. Fusion's pretty laggy for some reason when I have this sharing on, but it's not critical. I'm going to go with a nice little 2-degree taper that generally works for all injection machines.
Is this for the draft, you mean?
A draft, yeah, draft.
Yeah.
Draft angle.
Yeah, I went crazy with my draft angles. I just made them super, super big. And it's kind of like the main feature of the industrial design I'm doing is like centering around these really wide angles. So I'm not even worried at all about the draft angles.
How big are we talking here?
Like 30 degrees.
Oh,
Whoa, okay.
The main angle for the port is 1.5 degrees. I think I can get away with that. But the rest are like huge, giant degrees so that I can just give it a little bit of a design flair. So I have this trick for making the bottom. All right, so I just shelled out my top. Now to make the bottom, I want it to nest in. So there's this trick I have where I'll go right back before I shelled it. And I will select the shape and copy it. And I'll call that bottom. I'll go to the shell tool and I will shell out this, but I will leave the bottom intact, and then I'll just subtract it. Now I've got my bottom as a separate part that fits perfectly.
I'm going to be making openings for buttons that I will probably change later.
All right, time to add some screws.
Already adding screws, man.
Well, I'm starting everything from scratch here from the PCB because I don't know what it was doing, but it didn't accept. I couldn't do the shell or anything. It completely refused. Okay, finally got an outer enclosure. Gonna try shelling again.
Good luck. I think I might be jumping the gun with how I'm doing this. Like I'm gonna put myself in a corner later, but
love doing that.
Look, you gotta live life on the edge, man.
Now I'm gonna draw my screw holes. So now I'm drawing some ribs to keep the PCB down.
Austin, are you building like little tubes that go down from the surface?
Yeah, my thinking with these sensors is that I want to have it make sure that they can be able to sense. So I'm having these tubes come down to meet it. And I'll put reinforcement ribs and stuff there. Right now, I'm trying to place down the core elements.
I would do the same, yeah.
All right, so I got these ribs. Now I got to cut them up so they fit a little better. I just went back in time before I shelled anything, and I'm going to make a duplicate of this. And that duplicate will be the guy who chops up my ribs.
That sounds painful.
No, they love it.
Yeah,
they love it.
Some violent stuff going on over there, Alex.
I know, chopping up ribs, man.
All right, my ribs are chopped up.
Okay.
Does the sensor need to have access with a hole?
Yes. Ideally, maybe some small holes. It just needs to be able to sense the ambient humidity. It's a temp humidity sensor.
Got it. All right, so I'm going to make some slot holes over here for our lovely sensor.
For those people watching, yes, I did delete something and then just redo it. I just did the same thing twice.
Only twice?
Adding in some draft because I was forced to.
Peer pressured.
I like that strategy where you design it first without, just to get it printed and tested and stuff, and then you can worry about.
No, it makes the most sense because you don't want to like waste time on industrial design when, for all you know, that feature's not even going to be in the final product. All right, just put all my holes in there. I hope the area around the button is big enough, but I'm gonna give it a chamfer. Actually, I'll give all of these a chamfer just to make it look a little pretty. I'm gonna start doing some draft angles now, just to do the ones that I missed. So what I'm gonna do is called draft analysis. And this shows us what areas in the design will have trouble in the injection molding machine, and they all have turned red here. Like areas where it can't come out of the injection mold.
See with Alexander's design, and you see he's used these ribs, and the reason he's doing that is for injection molding. You want the uniform wall thickness, so you don't have any thermal cooling difference between, if you have a big chunk of plastic, that's going to take longer to cool, so you get a temperature differential that can cause warping in the...
That's exactly right. I think I'm done. I don't really know what else to do to it.
Whoa, okay. Can you go ahead and give us a review then of your design, Alexander?
I thought it'd be cool if you didn't see like a parting line. And,
can you explain a parting line for those?
Yeah. Well, I mean, I don't even mean parting line. I mean like when you take the two parts and put them together.
Oh, okay. The line between the two halves. Okay, gotcha.
Yeah.
Okay.
Well, I thought it'd be cool if you didn't see that at all. So I designed it where the bottom completely nests inside the body. So this is what it just looks like. So there's the bottom completely nesting. So I have it completely nest inside. And then here we have flush mount screws. Let's see, we'll explode this a little bit. The ribs here hold the PCB. So it gets pushed in, and then also the ribs hold the bottom. So you can place the PCB in and it should land flat on there, and then the bottom will rest on there as well and just completely nest inside like that. And then we have the parts where the screws go in. Got all my holes up here. And then, like I said before, like I wanted to have some industrial design to this, so I just kind of randomly threw on this giant hump. I hope it doesn't look like a car. That wasn't my intention.
Oh, no, I didn't think of that, but now that you mentioned it, it kind of does, like a futuristic car.
I made all of my dimensions really big so that I could go back in time and tighten it up. So I will bring in these walls a little bit, make sure I don't break anything while I do it. So just for the people watching, if you go too far, see that's turned yellow? That means I broke it, and I don't want that. So I just was staring at my part and I just added this extra feature, and I'm deciding if I like it, and then I realized it breaks the rules of injection molding. It makes a negative draft.
What feature was that?
I put this little groove here. I thought it looked cool, and then I realized like, no, the mold can't come up because of that groove.
Do it, Alex. No, Alex, I'm sure it's really good. You should do that. Add that feature in there. It's good.
I'm gonna delete that.
What's your status, Austin?
It's all right. It looks like a remote, but it accomplishes, I think, most of the tasks. It just doesn't look very good.
Yeah, it's definitely interesting looking.
Yeah.
So you have yours is screwed together too? Is that what those tabs are?
It's just going to be 4 screws, one there, down there, and it's just kind of held in place. And that's basically it. So I'm pretty much done. I've met all the main requirements. It's ugly as sin, but it gets the job done.
Oh, and you made some actual buttons, it looks like.
Yeah, I made some actual buttons in there.
Okay.
They're just kind of contained between the button area and this little top piece.
I'm also pretty close to finish, just making some of the LEDs and stuff correctly. I wanted to do buttons, but in the end, because of all the time I wasted on software stuff, I decided to skip that, to go straight to the necessary. Well, I might as well call it finished at this point. It's functional, it's ugly as sin, but it's functional.
Okay, excellent. So Alexander's already reviewed his design. Austin, can you just kind of go through and talk us through your design, and then I'll have Alex do the same thing?
Yeah, so my design was inspired by an LG TV remote, and basically has kind of a thin layer. I'll actually show an animation. It has the main layer on top. I tried to have these areas that came down and would meet these sensors here, and also try to act doubly as the way to divide them. And then from there I have the buttons that are kind of retained between this top layer and this bottom, and the buttons there, and then the main body. The board is just kind of just sitting in there. It's placed so that it's not being clipped in or anything, but it's contained by the walls and whatnot. I really wanted to do more of it like a snap fit, where there were maybe 2 clips or 4 clips, then it would just kind of clip together, and then that would eliminate the need for screws, but that would be an iteration 2.
Austin, I'm seeing your full enclosure. Where are the 2 pieces? Like your parting line, for instance, is it going to be hidden like it was for Alexander's, or do you have like a flat plate, or is it 2 halves? Or
so this part here, there would probably just be, I don't even know, correct me if I'm wrong, I don't even know if this part would necessarily, the parting line could probably actually match this area here.
I think it's almost like Alexander's, where
yeah.
you just have the entire part in one
Right.
mold.
That's what I was going for there.
Okay.
And then there would just have to be a separate piece that's kind of a plug that's fitted in here for the opening. So it'd all get molded together. This plug there would then remove, and then, you know, this part of it would lift up and you would have your part. This is abnormally thin. I shouldn't have gone this thin. The thickened tool was kind of being a bear, so I stuck with currently 0.5 millimeter. It's 0.5 millimeter all around. So this would definitely be really flimsy.
I thought you were doing 1.5 millimeter.
I was for the body, and then when I made this part became 0.5 millimeter thick. The saving grace here could be that because it's supported by this outer wall and it has these ribs here, there could be some structure there, but more than likely this would have to be updated to be thicker, you know, be 1 millimeter or something like that.
Alex, do you want to maybe go through yours now?
So since I had so many problems, I went with an absolutely basic enclosure. The thing that I did focus on is manufacturability, so I made sure there was a purely 2-part molds for each part and nothing else. So that would really represent minimal cost in terms of fabrication, with just 4 screws, and the PCB is held in place via pressure basically between the 2 parts. One of them has hollows and the other one presses the PCB down in there. The concept is at maximal simplicity with just the greatest basics possible. You see for all of the buttons I just made holes, so presumably you're pressing them with a pencil or something. And I did surround them properly, as you said, to avoid light leakage and everything, heat leakage from your lead and everything. But apart from that, it's a really basic and functional design. I did do injection check right now, and it's 100% perfect for a quick injection molding, so there's always that. What I could definitely have done here if I had the time was, instead of having buttons, have, you know, shaped cutouts so that the plastic flexes a bit when you're pressing on it, and that acts like a button. Then you're not making extra molds. That would be the minimal price solution right there.
I don't see any screw holes or where the screws are.
They're on the other side.
Oh,
right
they're on
here.
the bottom side. Okay, there you go.
I made sure that all the screws are on the bottom side. I always do that. It's a question of principle.
That's good. It's aesthetically pleasing, yes. But both of yours is fantastic. They look really well, really good. They've got good features to them.
Mine could hardly be more basic.
Well, the features I think for you are more hidden than they are on the outside, so I really like both of them.
Yours is definitely well thought out when it comes to sensors and everything. I can see you really put the right shape in it.
I was trying to focus on that portion of it. Don't like what I've done, but I appreciate it. Thank you.
But I think adding buttons with cutouts and adding some logos, some appearance, smoothing it out a bit, there's a lot of potential that you can do to make things very cheap to make and yet functional.
Yeah.
This was the trial run, right? We get to do this again?
Yes. And the winner is Alexander Simone of MakeXNow.com. If you enjoyed this battle video, then definitely check out this one next.